Okay, so hello everyone, welcome to the seminar. And today Manolis will be presenting his paper with Alessandro Gavazza. Before his presentation, here's just a brief announcement. The format of the seminar is that Manolis will be presenting for 60 minutes. During the 60 minutes, so attendees in the audience can ask questions in the Q&A window, and Alessandro will try to answer them. And there will be also a 15-minute Q&A after his presentation. And if you have questions, we can also unmute you then to ask the question. And after the seminar, we'll post a recording on YouTube. And also, so just an advertisement of upcoming events. In November 13, there will be a workshop for job market candidates who work on search and matching. And in 2 weeks' time, Pierre-Colin Dauverens will be presenting his paper. Yeah. Manolis, I will give you the floor.
Okay. Okay, so you can see my slides. Yes. Okay. Great. Yep. So thank you very much for having me here. As Sheng-Jing mentioned, this is joint work with Alessandro Gavazza, who will be answering questions at the chat. So the title of the paper is Regulatory Interventions in Consumer Financial Markets, the Case of Credit Cards. So after the financial crisis, the regulation of consumer financial products increased substantially all around the world. So in addition to the creation of new regulatory agencies, perhaps more importantly, there was a big shift in regulatory attitudes. And that included the implementation or discussion of direct regulation of prices. So things like interest rates and fees, including the introduction of price caps for some loans, credit cards, and other types of loans. Now, I think it's fair to say that before the financial crisis, such a policy instrument would have been considered extremely blunt, but this is something that's now gone a little bit closer to the mainstream. Okay, so that brings up the question of what is the likely effect of a cap on interest rate on loans. So the standard competitive theory, what we would teach in undergraduate microeconomics, has a very sharp prediction. Such a cap would lead to a reduction in market efficiency and a reduction of consumer surplus, particularly for marginal borrowers, particularly for the borrowers that such a cap is supposed to help. And the intuition is very clear. You know, people pay high interest rates for a reason, according to the competitive theory, because they are riskier. And therefore, if you impose a price cap, these guys are going to lose access to the market, and therefore they will be worse off than having access to the market, albeit at a high interest rate. Now, the people who propose such caps, of course, they're motivated by the perceived absence of perfect competition. So for those proponents of the caps, this particular prediction is irrelevant. So what is the relevant question for them? So the relevant question is, what is the likely effect of such an interest rate cap on potentially imperfect markets? Okay, and to answer such a question, we need to first of all measure or somehow quantify the extent of imperfection in a market, and we also need to determine sort of the response of market participants to different kinds of policies, and that's the goal of this paper. And we will try to answer such questions, focusing on the U.S. credit card market, for which there is a lot of evidence of of market imperfections. And there's also a significant regulatory interest. So this is a very relevant market to study for these types of questions. So let me give you a brief overview of what it is we do in the paper.
Well, can I ask a quick question just about the motivation?
Yeah.
So you kind of use this distinction between, you know, perfectly competitive versus not, to frame this question about capping interest rates. But you didn't say anything about like the other friction that I think a lot of people think about when they think about credit markets is information frictions, and we know you can have,
okay, so here I want to think of imperfections in the broadest, at this point, at the broadest possible level. So I'm not telling you whether This is because of search frictions or information frictions. It could be anything.
Okay, but when you say standard competitive theory, you mean a frictionless, you don't mean Rothschild-Stiglitz. You mean
No, full and complete information, everything, yeah. And when I look at the data, okay, so the first thing we'll do is we'll look at some data, and then this data will inform us about whether we think, one or other type of, frictions, informational frictions is important. So we have access to, so we're going to use two detailed data sources, which will provide evidence. So I'm going to describe two stylized facts about the data on credit cards, which are interesting in and of themselves, but even more so in combination. So the first finding is that we have data on the interest rates that people pay on their credit cards, and in particular when they roll over their balances. And we find that the interest rates that people pay are very high in compared to the funding cost of credit card companies. And perhaps more importantly, they're very highly dispersed. And this dispersion persists even after you control for observable characteristics of the borrowers, including the most widely used measure of repayment risk, which is the FICO score. Okay, so that's a credit score in the US for those
Manolis,
of you there. Yeah.
when you talk about people paying high interest rates, are you counting just the people who actually don't pay off the balances, or?
No, yes, as I said, yes, exactly. I'm looking at the people who carry over their balances. So the people, so this is not the people who use the credit cards as transactors, as a means of payment, as a debit card. These are people who actually borrow on the credit card and for whom the level of the interest rate actually changes their payments to their credit card companies.
Thanks.
So this first finding suggested that there is a lot of market power in this market, in the credit card market. The second stylized fact comes from a different survey dataset, which consists of credit card offers that people receive. So these are pre-approved credit cards that are, at least when I was in the US, they would usually arrive in the mail. And these are pre-approved, so you only need to say yes or no if you would like to take this credit card or not. So people receive a lot of those, as you know, I'm sure you're all familiar with, and there's a lot of dispersions in the interest rates in those credit cards. So this second finding would suggest that lenders actually compete quite fiercely for customers in this market. Now, those two facts taken in combination, they seem to be sort of in conflict with each other. In particular, if individuals were to accept, so they receive a lot of offers, and if they were to accept the lowest interest rate offer among those, then we would expect that the accepted interest rate distribution would have a lot less dispersion and the rates would be a lot lower than what we observe. Okay, so there is a bit of, there's a feature here which seems a little bit puzzling at first sight. Okay, so this is just a description of the data. I'll give you a lot of details in a little bit, but this is just in terms of words. So the first contribution of the paper is to develop a model of imperfect competition, which is going to be based on search theory. And we will introduce two separate channels to rationalize this somewhat puzzling observation. So we will allow, so again, the goal is that we want individuals to accept some high interest rate offers, even though they have low interest rate offers as well. So the two channels that we will introduce to reach that goal is first, we will have endogenous examination effort. So borrowers or potential borrowers, even though they receive a bunch of letters with credit card offers, they will not open all of them, or they will not examine all of them. And this will be an endogenous decision. And so they might receive some very attractive offers, but simply because they didn't open them or they didn't examine them, this offer will go, they will not accept it. Okay, and just as a sort of motivating fact here, not factor, as a motivation, this is not meant that it's difficult to actually literally open a letter. It just might be difficult to compare across different multidimensional offers. Okay, that's just an interpretation. Okay, so the second reason why people might accept high interest rate offers will be product differentiation. Okay, so this is a very common feature in industrial organization models. And so the idea is that potential borrowers will value other aspects of the credit card that we as economists do not observe, but where that the borrower does observe, of course. Okay, and this might also lead some borrowers to accept a credit card with a high interest rate and reject a credit card with a low interest rate. Okay, so that's the theoretical contribution, developing this model and characterizing this model. And then we will calibrate the model to the data. That will be our quantitative contribution. And this calibration will help us quantify the importance of each of those two channels. And then with our calibration, we will be able to perform counterfactual policy experiments to answer the questions that I began with. So in particular, what would be the effect of a cap on interest rates? And we will also examine the effect of an increase in lender operating costs. To examine basically what happens when you impose more costs because of additional regulations.
Manolis, can I ask a quick question? I mean,
yeah. Yes.
In the first bullet point, you're talking about on one side you have this market power and saying that these guys, because high interest rates, they have market power. But the second one, you say, well, these guys compete fiercely for customers. That typically, I know in the model is whatever, it will all work out, but in some sense at the basic level, they seem to be kind of to be competing stories. Now that we think that if they're competing hard for customers, they should be kind of low markups or low market power.
Well, exactly. Those two, at first sight, they seem to point in opposite directions.
Yeah.
And so we'll try to have a consistent story that includes both features, and that's going to be actually very important. And I will explain as we go along, exactly why this is important.
Okay.
But this is precisely that's going to be at the heart of the analysis. So let me give you a two-line sort of description of what we find. So first, we find that the endogenous examination effort is extremely important for understanding these features of the data. So product differentiation is not very important. So basically, we estimate or we calibrate these examination costs to actually be very, very high. Okay, so for the next steps, so beyond this paper, trying to understand a little bit further at a deeper level how this market works, I think that's, understanding where this high cost comes from is going to be actually quite important. The second, in terms of our counterfactuals, the second main result that we have is that the cap on interest rates is actually going to increase consumer surplus substantially, particularly among the marginal borrowers. So this is particularly among the borrowers that sort of standard competitive theory would predict that would be hurt from this interest rate cap. So in some sense, we get a reversal here of results. And I'll try to explain in great detail about how that comes about. Okay.
Yeah, a quick question. Do you consider switch cost if consumer receive a favorable offer, but there may face switch cost?
Okay, so we don't, right? So both our data and our model is going to be relatively static. So I should say, in the data that we have on the interest rates of people's credit cards, what we observe is that people tend to keep their same credit card and the same interest rate for a long time. So I don't know exactly how that would fit in sort of a switching cost kind of story, but we're not going to have dynamics here about switching and so on.
So on your last point, if I may, so in Burdett Mortensen, a minimum wage can be either welfare improvement or it's good for the marginal workers. Is in that sense this sounds related, or is this completely different, the mechanism?
No, it's going to be quite different, as you will see through this search effort story. But let me defer exactly where this improvement comes from. I'll try to explain it in great detail. Okay. All right. So if there are no further questions. Okay.
Manolis, so can I ask one quick question? Is do we observe something like the reward or cashback? Because maybe
yes, I will. Yes, we control for those to the extent we can. Yes.
Okay, so the industry is already controlled for that. And
yes,
another quick question is so that maybe some people know more than I do, is there's a big literature in structural IO estimating the multi-homing So what will be the advantage? I'm just wondering, doing this approach.
Estimating what, sorry?
Huh?
Estimating what?
The structural IO, so they are estimating the multi-homing. So for example, I have a competition with the multiple credit card. So, but different credit card can have different features, like they have different interest rate, different cashback, and they are estimating, okay, from that approach. So then the switching cost, like in Q1, will be important.
Right, so let me describe the data here. And I think I will, through this description, I will address some of the questions that you answered. Okay, so now we're getting into the details of the data. So let me do that now. Okay, so there's 2 survey data sets, as I mentioned, and they are presented in this paper by Stanko and Zeman. So the first data set is the interest rates on the credit cards that people have in their wallets. So in the search lingo, I guess this would be the accepted rate distribution. Okay, and it's basically lasts for 3 years. So as I mentioned before, we're going to focus on individuals who carry a balance. We have a lot of information about them and also about the credit card characteristics. And we're going to split individuals in 4 groups according to their FICO scores. And these are the 4 groups that the credit card industry uses. So subprime, near prime, prime, and super prime. So this is one data set that we will use heavily. The second data set we will use heavily consists of interest rates on pre-approved credit card offers that people receive in their mail. Okay, again, just to emphasize, especially for the people outside of the US, these are credit cards that for which the individual who receives the letter has been approved. So this is not an invitation to apply. This is an invitation to say, yes, I do, so to speak. Okay, so this second data set comes from January 2007, and that's the period that we will focus on. And then we have some aggregate data. I guess I should say that we have the average funding costs for credit card companies. That's something important we will use. Okay, now let me show you.
Do you see any other aspects of the offer beside the rates? Or?
Yes, so we know, okay, yeah, so we know teaser rates, so we can control for those. Yeah, I don't think there's something else that's important. Let me, right. Now, what we will use for this, no, sorry, Alessandro, do you, I am blanking out here if we have much more information.
We don't have the data directly, so we only have some aggregate statistics on the offers. But as Manolis, I think, will show you in a second, when we compare the received offers with the accepted offers, there are quite some similarities. So it doesn't look like the received offers are just a weird sample, if this is something that you're worried about.
But is it a question of, do they have miles or cashback or other characteristics besides the interest rate?
Okay, so what we will show you here is that for the accepted rate distribution, it doesn't make a big difference. Okay, so let me just show you on this slide. Okay, so here I'm focusing on near prime borrowers. I will show you the data on the other groups in the next slide. Let's focus on column 3. So this is just the raw data. These are different percentiles of the interest rate different distribution, having taken out the teaser rates. So these are low rates that you get for a short period of time when you sign up to a credit card. So we're getting rid of those. And there's no other, this is just the raw data. So what I would like you to see here is that—
Wait, Manolis, can I just ask, so does that mean 26,000 of what you see had teaser rates and you're left with—
No, sorry, okay. So 1 is the full data. 2, column 2 is restricting the data to January of 2007.
Oh, okay.
Right, so this is just a temporal restriction. And then from 2 to 3 is getting rid of teaser rates, yeah. Okay, so here, so what I would like you to note is that the distribution is hugely dispersed. So basically going from the 10th to the 90th percentile, you have a 16 percentage point difference. Okay, so that essentially, that given the average balance that people roll over after a month, so they pay interest on, that moving from the 90th to the 10th percentile would save the average borrower something like $500 to $600 a year. So this is a very significant amount of money. Okay, it's not trivial. Okay, now, so near prime borrower is a specific group. Of course, it could be quite heterogeneous, this group within itself. So the next thing we do is we control for the FICO score. So we control for essentially the most widely used measure of repayment risk.
Manolis, a quick question before you keep going. So how do you think about, you're talking about that this is only for people that actually have debt, no? So if I get my credit card, I use it as a debit card, I don't appear in this data set, right?
Okay, so in the final column, we focus only on people who have debt, and it doesn't change very much actually. Yes, but we will focus on people who roll over their debt, and we also do this the exercise I'm showing you here for balanced weight accounts. It doesn't really change very much.
Okay, cool.
Yeah. Okay, so in equation 4, we just regress this, in column 4, we just regress the interest rate on the FICO score. Okay, the regression has the expected sign. So higher FICO score means higher repayment probability and lower interest rates. Okay, but the thing to note is that the R square is less than 2%. So basically, within each, and this thing holds within each of the 4 groups. So basically, there's this huge dispersion, but this is not explained by individual heterogeneity in repayment risk. Okay, which is actually quite it's quite shocking. I mean, I think it should strike you as shocking. So if you look at the residual variation in interest rates, it's essentially the same as before. And then you can throw the kitchen sink on this. So we have information about whether these are reward cards, the credit limits, the credit balance of individuals, and so on. The main picture doesn't change very much. And the residual variation in column 6 here is essentially the same as before. The 90 to 10th percentile difference is 16 percentage points. And this is again, column 6 focuses on individuals who roll over, so basically who do not repay the credit cards at the end of the month, but who pay interest payments on their debt. Okay, so what to make of this? There's a couple of.
Can I ask a question?
Oh yes, yes. Mm-hmm.
So the way you think of this is that this dispersion from 13 to 29 is the logic that you want to impute this to like random useless stuff? Is that the logic that you're going to throw the model with? Just to know where we're going. That these enormous.
Okay, so the logic is
the two of you have been unable to trace where it comes from. Perhaps reasonably so, but still you haven't been able to find why it's there. You're going to say, when I have a model where this amount of dispersion is going to trace back to essentially useless stuff. Is that the logic that we are going to pursue?
Right, so the logic is we have a lot of information about these individuals, including the FICO score, and that seems to be orthogonal to sort of these interest rates. So we're gonna, so in order to understand this variation here, we will need to move beyond individual characteristics, and we're gonna use market structure in some way, in a particular way, which I will model.
And you think that this is the only credit card they have? This is the one that they are all using, that these credit cards are defining the marginal interest rate? And you're going to be thinking that some friction made them be settled on this one. Is that where we're going?
Sorry, I didn't, some friction, what? I didn't.
Some friction is going to account for why they settled in here. Nothing unobservable. Nothing.
Okay. Right.
They don't
so
have
we will allow
credit cards. These interest rates are going to define the marginal, the interest rate that enters over the equation.
So we will allow for, I guess, I'm not sure if that answers your question, but we will allow for some product differentiation. So some unobservable feature that individuals like, so unobservable to us, that makes them choose particular one credit card rather than the other. And basically.
Okay, excellent. So when you later make sure that you tell us how the model is going to.
Yes. So I will tell you, and then basically, yeah. Okay. I will be very explicit because that's important actually. Okay. So the first thing is that we're going to impose a market structure here, and the second thing is that within each of these groups, so I'm showing here a near prime, but the same thing holds for the other 3 groups of borrowers. So the repayment risk heterogeneity within the group does not seem to be a first order explanatory variable for this dispersion of interest rates. And so for this reason, which will inform the assumptions that we make in a second. So just keep that in mind. Okay. Okay, so here's the data we will use for the calibration. On the top here, so this is the near prime residual variation that I showed you. The other three columns are exactly the same calculations for the other three groups. Okay, just notice these are also similarly dispersed. Okay, and we have the fraction of individuals with credit card debt in each one of these four groups. Okay, now our second data set is this in this panel B here. What we observe is that 3/4 of people receive 2 or more credit card offers in a month. And on average, they receive, among these, they receive 4. And these credit cards, again, come at very dispersed interest rates. So the within person now, this is within person variation, is 4 percentage points in the median, okay? Between the highest and the lowest credit card offer. Okay, so these are quite dispersed. And yeah, okay, and we have the charge-off rate and the average funding costs. Okay, so that concludes the description of the data. So, and then the next step is to go into the model. Yep.
Do you know whether there's heterogeneity in terms of how many offers people get? Like
Yes,
better
yes.
credit risks, do they get more?
Okay, yes. So this, yeah, this is one thing. We don't have the micro data for this second data set. So unfortunately, we don't know about the distribution of numbers of offers across individuals. So we only have the aggregate, unfortunately. Yeah.
One other data question, Manolis. Do you have data on how many credit cards different individuals carry?
Yes, in our first data set, which I don't have here. Yeah.
That seems important. I mean, a couple of people have already asked, basically I could have 2 cards, one that gives very generous rewards, but has a very high interest rate, and then carry a second card that doesn't give me anything, but has a low interest rate, and I can solve some of this trade-off between amenities of the card and the interest rate by carrying multiple cards.
Yeah, so as I said, we're looking at the dispersion. We're going to take the interest rates for the credit cards, not individuals. This is an account-based data that carry debt. So if the person has debt on a particular credit card and holds 10 more that he doesn't have debt on, we discard the rest. We focus on the account with the debt. Yeah. Okay, so now I'm going to move to the model. So the model is going to be static, and there's going to be
before that, can you tell us what is this? I always like a minute or so to hear what is the model supposed to do.
Okay, good.
Rather than something you cannot tell me with a story and a beer. So what's the model?
Okay.
Professional tax.
Yeah. Okay. Good. So what will be the main sort of features that we want to capture here? So there's the one that I started with, which I think is the most striking one, which is the fact that people get these very, very dispersed interest rates. In addition to that, it has to somehow be consistent with the fact that they receive a lot of offers, and some of these offers are at low rates. Okay, so that's the first feature. The second feature, and that's important now, we're getting into a little bit more equilibrium analysis, is how could it be in equilibrium, an equilibrium outcome that firms offer these very dispersed interest rates? Okay, that's going to be an important feature.
But that's not an answer what I want. Obviously, how can you go wrong with those? Saying what is the model going to do? Something like it's going to give a chance to 2 mechanisms to carry the weight. It's going to impose only one mechanism to carry the weight. It's going to decide that these simultaneous going to do is to think we're going to pop people, we're going to throw people with different things. They're going to choose 0, 1, 2, and I'm going to use the model to measure how costly do these things have to be, given my calculation of the benefits of choosing one. So that's what I mean. What is the model supposed to do? And equilibrium is not part of the
Okay. So yeah, okay, so that's the method. Yeah, right. Yeah, so here, so the model is gonna have these features, there's gonna be frictions, there's gonna be product differentiation, there's gonna be this examination cost, all of which might play a role, and it's gonna be important for the counterfactuals, which one of these features is more relevant in the market. And each one of these features is gonna have some different predictions about different dimensions of the data. Okay, I'm being a little vague here. I will be precise about this later on. So the idea then is to understand what are the main sort of driving forces in a model that can rationalize this data. I'm not sure I'm giving you.
I'll come back later to see if I'm not happy. That's okay. Keep
All right.
going.
Okay, so the model. We're going to look at each one of these 4 borrower groups separately. So each one of these groups is going to be a separate market. Each market will consist of borrowers. So measure 1, heterogeneous in their willingness to pay. So as I mentioned, the model is static, so any dynamic considerations are essentially, in this Z. And within a market, there's going to be the same default probability for all borrowers. And the motivation is, what I showed you in the data before, that, heterogeneous default probability does not seem to be priced, at least not very strongly in this market. So lenders, that's the other type of agent in the market. There is potential measure lambda of lenders. Lenders are heterogeneous in terms of their funding costs, and they have 2 decisions to make. The first decision is whether to enter the market at cost chi, and I will denote the entrants, the ones who do enter the market. They're measured by L, and their cost distribution by G. And the second decision that lenders have to make is if they enter the market, what interest rate do they offer? So a lender here, you should think of a lender as a credit card offer, not a company. Each lender is going to make one offer. And now there's going to be frictional matching between borrowers and lenders. So every lender has one loan offer and sends that loan offer to a random borrower within this group. So a lender, this group of borrowers. So a lender knows whether he sends an offer to a subprime borrower or a super prime borrower, but does not target to a specific one within. Okay, now borrowers have 2 decisions to make. So the first one is how much effort to exert in examining these offers, okay, E. So E essentially is what proportion of the offers do the borrowers examine on average. So therefore, every borrower in the end is going to receive and examine N offers, which is going to be a random variable, which will be drawn from a Poisson distribution with parameter E times L. So L is the number of offers that arrive on average. E is the proportion of these offers that the borrower examines on average. So that's the resulting distribution for the number of offers that the potential borrower has at his disposal. So that's the first decision. And the second decision is once he has these N offers, he can examine their characteristics, which is going to be the interest rate and this product differentiation attribute. And then the borrower is going to choose one or none of these offers.
Manolis, a very basic question.
Yeah.
So are borrowers heterogeneous in their default probability?
No, they're not. They're homogeneous within each of these groups. And the motivation, again, for this assumption is that the interest rate within each of these groups does not vary in any meaningful way with the FICO score, so the public information about their repayment risk. Okay. Obviously, in reality, they are heterogeneous, but yeah, but that does not seem to have first-order implications for pricing. Okay.
So let me go back to the beginning. So what you want to have in here is that you want to have a model and you want to find out how does it take for some people to be stuck on the bad one. When you're seeing people holding much higher interest rates than others. they're paying real dollars on that, you're going to assume they got an offer on the mail that was a much better deal, and they chose not to open it, and that's why they're stuck. They would choose the best among the ones they open, but like in the exterminating angel, something prevents them to open the envelope, and you want to get a measure of you're going to get a measure of how costly it is, allowing also a possibility that they opened the good one, but they didn't like the color that the bad one had.
Yeah.
And that's why they made them call the bad one. You're trying to measure those two things. Is that where we're going?
Yes. Yes.
Yep.
Okay, yes.
Or by chance, they just got a lot of crappy offers.
Yeah, that's fine. But that's a thought that
Yes.
the assumption now, the assumptions of this, you open them randomly. There's a lot of money to be made by firms. Even
Yeah, but they have a lot of offers, so chance on itself wouldn't be, just the Poisson probability itself wouldn't be enough to.
Okay. Yes, to tell us later how does.
Manolis, you mentioned that there's not much variation by FICO score, but maybe Igor and some of these other guys who know the empirical literature better can tell me this too. But is there correlation between the guys who accept the higher interest rate and default? I mean, could there be unobserved heterogeneity? I mean, unobserved meaning conditional on FICO scores and things
within FICO score. Okay, within FICO score and default, I don't know. Yeah, so that I cannot say. But the idea is that the FICO score is at the first order is the most widely used measure of repayment risk. So that's our starting point here.
I mean, it goes. I think Victor mentioned this before. I'm just trying to get at the idea. I mean, there could be unobserved heterogeneity on the borrower side that these guys use different rates to screen, right? So.
Right, but that would be essentially. But they would first use, in some sense, the idea would be that first they use the observables, okay, and then they use the observable, right? So in this sense.
But you're showing that there's incredible variation conditional on the observables, right?
Right. So that what you seem to suggest then is perhaps the observables are not so useful anymore, so they use something else.
I don't know if they're useful or not.
Other
things might be useful.
Yeah. So that would be, but I don't think that's. I haven't seen much to suggest that this is the case here. And yeah, so I don't have anything particularly insightful to add on this, except perhaps that we will allow for some measurement error that will give us a sense of the stuff that we put in the model, how much is left out, how much variation cannot be explained, and that will give us a measure of how good is the fit. Okay, but I'll discuss this when I get there. Okay, let me move on with the model. So this is a one.
Could you go full screen, because we cannot see the last line of the slide somehow?
Yeah, you will be able to see even less. I fear.
Oh, okay. It doesn't make a difference.
Maybe that's better. Okay, sorry. Yeah. Okay, so now I will. So that was sorry. This is one slide description of the model. I will now go and give you some more details about each step, starting kind of from the bottom up.
Manolis, can I ask one question?
Yep.
So here they get a number of offers and then they accept the best offer that they get. I guess in the data, part of the variation may come from, I might have 3 credit cards with different rates, but for some reason my balance is not on the lowest one. This is something in the micro data you should be able to see, right? Is that important quantitatively?
So for us, if you have a low interest rate credit card and for some reason you don't put your balance there, that we will not interpret here. We will just interpret why you might not accept a low credit card, but that I don't know. Yeah. Okay, so the utility of accepting an offer once you have a bunch of offers is going to be Z minus C. So Z is the willingness to pay for a credit card. C is the cost of the credit card, which has 2 components: the interest rate, which is endogenous to the model and determined by lender choices, and A is the idiosyncratic attribute that I mentioned, which is drawn is borrower specific, and it's centered around 0. So this is going to be horizontal product differentiation. I will discuss a little bit later. So we consider an extension with vertical product heterogeneity, product differentiation, meaning that some credit cards consistently get better draws. They're just better for everybody. It turns out it doesn't make any difference qualitatively for our results. So the distribution of costs is given by this expression here, is just the sum of two independent random variables. Okay, so as you've already anticipated, a borrower is going to choose the lowest cost among his offers, so long as that cost is below his willingness to pay. Okay, that's fairly straightforward.
So one thing here to make, when you estimate the model, which you should try to upgrade the word from calibration to estimation, you want to get something about the relative variances of these two babies.
Yes, exactly. Yeah, absolutely.
But you should give it a chance to have some correlation being meaningful, as to make sure.
Yes. So we did this in an extension. Sorry, a correlation.
Come back later. You don't have to.
Yeah. Okay. All right. The other decision of the borrower is to choose his effort to maximize this expression here. Q is the cost of exerting this effort. V is the value, expected value of a loan, which depends on how many offers this borrower receives and examines, this P, okay, that's just the Poisson probability, times the value of having examined exactly n offers. And the value of examining n offers is essentially the utility on average, net of the cost for the lowest cost offer among these n offers. Okay, and then, so that describes the other decision of the borrower. And then the proposition is that given the actions by the lenders, so the number of offers and the distribution of these offers, we can characterize the actions, the effort choice of borrowers, which is going to be increasing in their type, as you would expect. So that gives us a mapping between two observable parts of the data, the number of offers and the offer distribution that comes from our second data set with pre-approved offers into the distribution of accepted rates. Okay, that's from our first data set, and into the fraction of borrowers who take out a loan, potential borrowers who take out a loan, which we have from aggregate data.
Manolis.
Yep.
Sorry, so this effort is literally the effort of opening an envelope. It's not a...
No, okay, so that's, all right, so our interpretation of that, as I mentioned, we will find that that cost is very high. Now, we can discuss about how to interpret that. We're not going to do something specific in this paper about this, but I think one way to think about this is that a credit card is a multidimensional object. It's not just an interest rate, even though that has the most kind of payoff relevant implications, but it could be, teaser rate, it could be a credit card limit, it could have different rate for advance, taking out money out of the credit card and so on. So perhaps it is actually difficult to compare across two credit cards. Okay, so. Yeah.
Right, but it could be also then a source of people ending up with paying interest rates that are in excess of their quote-unquote willingness to pay. It's just the way this maps to the data is affected by how you interpret it, right?
No, it does not. I mean, so this is we're gonna have a cost there, and then we can discuss what it means. Okay, let me move on because I mean, we can discuss implications afterwards if you want. Okay, lenders. Okay, very briefly, the profits of a lender. This is the first parenthesis here is the margin on a loan, so the interest rate, net of repayment risk, ROP, minus the funding cost, times the probability of giving out a loan, which depends on the interest rate. Okay, so the lower the interest rate, the higher the chance the borrower is going to accept the loan, but it also depends on a whole bunch of other stuff, the attribute draw, the number of other offers the borrower has received, the characteristics of those other offers, and the borrower's type. Okay, so that's a messy expression, but you can characterize it. Okay, so the optimal decision of the lender is whether to enter. The lender enters if he can, recover his entry cost, and he chooses the optimal interest rate.
So why would the firms only send one offer?
That's by assumption.
In Burdett Mortensen, you can think of the unit as a job.
This is not Burdett Mortensen. Okay, this is a different model.
Yeah.
So by assumption, a lender is one offer. So, all right, so the second proposition is we can characterize the policy of the lenders. So given their cost, we know what interest rate they will offer, and it's increasing in their types, as you would expect. So this gives us another mapping, again, from observable to observable dimensions. So from the entry, so the number of lenders and their costs, into the offers that they make. Okay, just to close the model, okay, you can characterize the entry condition, which is what you would expect. There's a marginal borrower such that, you know, if you have cost less than this K hat, you enter the market, and otherwise you don't. So that's the theory. Now let me move to the quantitative analysis. We're going to make some parametric assumptions. Let me skip those. Okay. All right.
Sorry, tell us where the identification
references are. Sorry.
I think the useful thing is to tell us how the identification works.
Yes, yes, I agree. We have a lot of moments, identification. Okay, good. So this is where I should go. Okay, highly nonlinear model. Okay, that's the usual, I guess, announcement. Okay, so three key mappings that I mentioned a moment ago, and we're going to use. So we have three key set of parameters, three sets of parameters. The cost of examination effort. This is going to determine how important this channel is. How variant are these draws of the product differentiation? So if this sigma alpha, sigma A, sorry, is the standard deviation of the product differentiation draws. If that is very high, then these idiosyncratic attributes of the credit card are very important for determining which credit card the potential borrower chooses. In particular, it's much more important than the interest rate. Okay, and then we have borrower preferences. So now I think this is, so this model mechanics, I think this is what Victor has been asking from
So why, remind me one thing, why are there any borrower preferences given the product differentiation? Isn't just a relative thing that
no.
It's about money and then some notion of differentiation, and you cannot tell whether it's fundamental in sigma or in preference.
No. So for example, borrowers with a high willingness to pay will exert more effort on average.
Okay, so you have this unobserved differences in preference.
Yes, okay.
So why would you need any of that?
There is a subtlety here. There is, okay, I cannot, yes, it's a little subtle. The important part is product differentiation and the cost of examination effort. And the borrower preferences play a residual role. But let me hold off on that. That's not very important for the mechanics I will describe now. I see your point. I cannot tell you right now exactly what the differences is, but product differentiation is the important one here. Let me describe a little bit the mechanics. I'll come back to this if you have a question. Okay, so now let's look at the second mapping here, from the offers that the borrowers receive to the offers that they accept. Okay. Now, remember that the accepted offer distribution was very dispersed. And if people accepted just the lowest offer that they received, we would see much less dispersion. So we need people to accept high interest rate offers. Either of the two channels that we have introduced will give us that result. High examination costs, well, in that case, if you have high examination costs, then there might be low interest offers that you do not observe because you didn't open the letter. High product differentiation, if that's very important, okay, if you get very high draws of this idiosyncratic attribute, then this might lead you to very often reject the low interest rate offer if in the event that that offer does not make a good draw. Okay, so just in the extreme case where product differentiation is hugely variant, okay, has huge variation, then you only decide on based on product differentiation and not on the interest rate. So either of those two channels could get you dispersed accepted offer distribution. So that part, the second mapping, does not help us distinguish between those two. However, in order to get a dispersed offer distribution, so in the first step, for that we need So that you cannot do with product differentiation alone. And the reason I think is it makes a lot of sense. If product differentiation is so important that borrowers essentially ignore the interest rate, in that case, there is no incentive for lenders to offer low interest rates. So all lenders would offer high interest rates.
Okay. But doesn't depend on the yield. If you have, well, that would depend on the yield. If the low guys, if the marginal cost of issuing one of those things is very high, isn't that? Or you're saying so this is true, no matter what the yield is.
The yield of what?
The yield of an envelope. If I send by mail at 30% interest rate offer, I'll get one guy in 100 because everybody's sending those.
Mm-hmm.
And somehow, if there were a correlation between the A and the cost of the A and the cost of and the interest rate, then you may be willing to throw a low interest rate if you're getting enough people. If you're getting enough people to say yes cheaply, or you're saying that doesn't happen.
Okay, right. So for this vertical heterogeneity, we're thinking actually the opposite, that high interest rate cards, would get better attribute draws. If you have low interest rate cards getting better attribute draws, then the puzzle, so to speak, of is even higher. Why do people accept high interest rate cards?
No, I was saying from the point of view of the issuer.
Yeah.
So if the issuer that gets, if there are many people, many companies sending 30% interest rates, and so you only catch only 1% of the mails that you say with the high interest rate card is accepted. But almost every low interest rate card is accepted. Would that be?
Yeah, okay. So if you have very high, if product differentiation is important, so the variance of that A shock is very high, then the interest rate does not determine the probability, does not affect very much the probability that you give out a loan. That's the key here. That becomes flatter because if there's no product differentiation, you offer 30%, I offer 29%, I get the customer. If there is huge product differentiation, okay, and essentially it's a coin flip. So you offer 30, I offer 29, we both get the customer with 50% probability. Okay, depending on which one of us is luckier in this high attribute draw. That's the thing. Okay, so that's exactly why. Okay, let me move on here, and perhaps we can discuss this later. So the idea here again is that with a very high variance in the attribute draws, you cannot get that some lenders will offer low interest rate offers, because there's going to be no advantage to offering low interest rate offers, because borrowers will not decide based on the interest rate, rather they will decide based on this attribute draw, which is completely random.
That's a crucial. I think it's the most important issue of this paper, and I think you would better put a little bit more meat in here, just to make sure that we see.
Okay, let me show you one picture. Can I show you one picture? So this is from the estimated model. This is for the blue line is the baseline case. So this is the cost of the lenders. The blue line is the interest rates that they offer in the baseline case. The red line here is a counterfactual. There's a comparative static, if you will, where we increase the variance of the attribute draw. And here we recompute, and this is for the new equilibrium, the interest rate that these guys, the lenders, decide to offer. What you see here is that it's much flatter. The reason why it is much flatter is that this low-cost lender was willing to offer a low interest rate because that low interest rate would compensate him, because it would increase significantly his probability of getting a customer, that lender's probability of getting a customer. Okay, and why would he do that in the sigma A, in the low, in the case where these attributes are not so important? Well, because the customer, the borrower who receives that credit card, decides mostly based on the interest rate. The variance of this attribute shock is low, and therefore the chance that it's going to overturn the relative ranking of interest rates is low. In the other case, in the counterfactual case, the red case, that variance is much higher. The variance of this idiosyncratic attribute is much higher. Therefore, even if you offer a low interest rate, still that is not going to increase your chances of getting the customer so much, because a lot more will depend on these draws of this A random variable, which is beyond your control. And therefore, the incentives of offering these low interest rates decline. And therefore, this schedule here, this interest rate schedule, becomes much flatter. Okay. So what this means now, so when we go to, okay, so this is model. When we go to the data, what this means is that the F distribution, the offer distribution that lenders would make, in this case of a very highly dispersed idiosyncratic attribute, that distribution would have very little variation. But in the data, we see that it has a lot of variation. Okay, so that cannot be the explanation for how this market operates. Okay, and that's and what Victor said is correct. That's that's at the heart of the model here. Okay, so I'm running out of time here. Let me just say, okay, we estimate or we calibrate the model. This measurement error is relatively low. So, okay, so the fit is good, even better. Right, let me just mention one thing. Okay, so here's the model implications for near prime borrowers. There's a lot of, we estimate a lot of gains from trade. So the cost of the lenders on the left-hand side is below the willingness to pay of the borrowers. For, red here is the distribution of types. And for borrowers, near prime borrowers receive on average about 3 to 4 offers, and they examine, around 1. Okay, so high Z borrowers examine more than low Z borrowers, but the average is quite a bit lower. Okay, so that's an illustration of the high examination costs that we estimate. Okay, let me move on to the policy experiments. Okay, let me just pause for 1 second. So the outcome of this estimation, and okay, so I've sort of iterated on that explanation many times now, but so the outcome is that to understand the data, we need a high examination cost and low importance of product differentiation. Okay, that observation is going to drive a lot of the outcomes of these policy experiments. So the first policy experiment is a price cap. So we set a price cap of 25%. So basically the model is identical. It's just that the lenders, when they optimize, they cannot offer more than 25%. So in equilibrium, the high cost lenders are going to exit. You should expect that. The remaining lenders are going to adjust the rates. So this 25% in the data would be binding for 1/3 of subprime borrowers and 25% of near prime borrowers. So here's the outcomes in this counterfactual world. And these are our outcomes as a ratio with respect to the baseline case. So first of all, note that for the prime and the super prime borrowers, these ratios are essentially close to 1 because this cap does not bind for these 2 groups. For the low 2 groups, it binds. And you can see that the average, now if you focus on the first line, the average number of offers per borrower declines by about 10%, okay, on average. Okay, so that's a very...
So this thing, one thing I can see what you're saying, let's don't get to the numbers, what you're saying is that you're preventing this guy's mailbox to be littered with junk that will do them no good.
Yes.
But somehow the surviving firms will not be hurt very much and they will just still send them loan. That's your logic. Okay? And
no, okay, no. There's another step.
Oh,
because
the numbers matter less than what's the logic that I would say.
No, okay, so here's, yeah, I'm telling you the logic, exactly this. So first, you have less junk in your mailbox, as you said, but also, it's not just less junk, it's better junk. Okay, because now this interest rate cap, it's more attractive for borrowers to open the letters, And what you see here is, even though you have this neoclassical response that the supply of loans in some metric declines, the effective supply of loans, the number of people who actually do get a loan, does not really decline very much. It actually goes 1% higher for near-prime borrowers, and it declines just 3% for subprime borrowers. Okay, what gives? Why does this happen? Well, because now these borrowers exert more effort to open these letters because the letters have nicer things in them. Okay, and the idea here, and the important thing here is that, because of this, when you impose this price cap, for sure you have less entry of lenders, but receiving letters in your mailbox was not the binding constraint in this market to begin with. Okay, and that's what we find here when we say that this examination effort is the main friction in the market, the most important friction in the market. And now we give an incentive for borrowers to actually try to overcome this friction, because now they receive better offers in their mailboxes. And as a result here, the consumer surplus actually increases quite a lot for these borrowers, especially for the low-end borrowers. And in terms of here, and just a graphical illustration here on the upper left panel, these are the lenders. These are the types of the lenders. As you see, so blue is the baseline, red here is the counterfactual. High-cost lenders go out of the market. The remaining lenders, you see, even though there's fewer of them, they actually compete more fiercely. Okay, they offer lower interest rates than they used to. So the same type, this guy over here, his interest rate is lower. Why? Because of this price cap. Okay, and that's what leads borrowers, which is here on the upper right panel, to exert more effort on average. So the highest willingness to pay borrowers, they actually reduce their effort a little bit, but the others increase their effort a little bit more. Okay, so on the aggregate, this is again for near prime borrowers, you can draw similar pictures for the subprime borrowers. So on the aggregate, there's more effort by borrowers here, which outweighs the decline in the number of lenders. So these other lenders, they were offering nothing here to the market.
Manolis,
yeah.
just following on Victor's.
One second, let me keep going. Yeah, let me conclude, because I think I'm running out of time, and we can discuss this in.
Sure.
Let me just mention one other thing, which is so you might wonder, is it the price cap that gives this sort of positive thing of increasing consumer surplus, or is it that we get rid of these high cost borrowers? So that's the point of our second counterfactual. We increase the entry cost, to replicate the set of borrowers who survive. And what you find is, if you kill off these high cost borrowers, but without imposing a limit to the interest rate that they can offer, then you're just left with a less competitive market, where two bad things happen. The remaining borrowers the remaining lenders offer higher interest rates than before. So the red line in this other counterfactual is higher. Again, remember, this other counterfactual has fewer lenders in the market. High cost lenders are out, fewer lenders remain inside, and they can offer whatever interest rate they want. So they offer higher interest rates, and as a result, borrowers exert even less effort than before. So as you see, for the borrowers in the upper left side panel, their effort choices is below, which is the red line in the counterfactual, is below the baseline, which is the blue. And as a result, here consumer surplus declines actually quite substantially by 15%. So you have the decline in the number of lenders, about 10% as before, which then is mirrored in a similar decline in borrowing, for the same reason. Okay, so let me conclude, and I think we can then have perhaps a slightly longer discussion after that. Okay, so since the financial crisis, so there was all this focus in enhanced regulation and even interest rate caps. Okay, so we built this model to try to understand the main features of this market and how they interact with these suggest potential policies. So we introduced these two elements, and we try to distinguish between them, and I guess we can discuss a little bit further about exactly how we distinguish between those two possible channels. But what's important here is that we begin by observing this large heterogeneity, this large interest rate dispersion, both in the accepted interest rate that people pay their credit cards on, and also in the offered rates. And these are things that we want our model to be consistent with. Okay, and so to be consistent with those two features of the dispersed offered and accepted distributions, the claim is that you need high examination costs. And of course, we can discuss exactly how to rationalize. What is that? It cannot be that it's difficult to open a letter. We agree. But once you have this high examination costs, then imposing a cap on interest rates actually increases consumer surplus, particularly for these marginal borrowers that, the straw man of, standard competitive theory would suggest would be hurt by such a policy. And okay, that's it. Let me stop here.
Can I ask you a question, Manolis? So let's say if I understood the data part, you get that once you control for observables, it's still dispersion, right, in interest rate and stuff.
Mm-hmm.
So can I interpret that as saying that if I were to write, why wouldn't write in a model that is all homogeneous, that are displaying the dispersion, the residual dispersion? And so why you need all this heterogeneity in the model? Like I thought that the data was saying, I control for heterogeneity, observables, and then I still have dispersion. So I thought it would be more like kind of a Bourdieu kind of thing that, okay, endogenously, I mean, you still have something like that there, I know, but you have all these other features in there that I'm not sure in which way they are coming out from the data. I think they're useful for the model, but.
Yeah, okay, so there's two reasons why we introduce this heterogeneity. One is to get a better fit here, because with example homogeneous workers, even with these additional features, only the exposed heterogeneity you get from this randomness is not enough, or might not be enough. And secondly, also for the counterfactuals. So, if you increase or if you impose this interest rate cap or this higher entry cost for lenders, then, we do want the feature here that high cost lenders are the ones who exit. So maybe their sort of, their composition changes. So we want to have that feature as a feature of the model. And similarly for the borrowers, as you saw, borrowers of different types here, exert different amounts of effort depending on their willingness to pay. So these are some features that we want to include.
Manolis, can I go back to some questions you got early, but I didn't fully understand the answer. So how are you dealing exactly with all the different benefits and costs and stuff that all the rich heterogeneity and the benefits of these cards, rewards programs, all that stuff?
So two.
I'm sorry, I know people asked you, I just didn't get the whole
answer. Yeah, no problem. So two part response here. So first, qualitatively, going from the 90th percentile to the 10th percentile of the interest rate distribution within your group would save you $500 to $600.
Yeah.
I think most of those rewards are nowhere near, for the vast majority of people at least, are nowhere near that amount. Okay. Now beyond that, we do control whether some cards are reward cards and so on in a somewhat coarse way, to be honest. But that coarse way doesn't bring anything up. But it just doesn't seem plausible that whatever marginal benefits some credit card might give you, it would amount to $500 per year. Okay, that's just not.
And you're also, I guess, controlling for the annual fees and things like that on these cards.
Yeah, we have some information on the annual fees. I mean, they're nowhere near. I mean, they're nowhere near as high. For example, for the vast majority of the credit cards.
Okay.
Yeah.
So you mentioned those very high inspection costs that we could discuss them afterwards.
Yeah.
So do you have any idea how we should interpret them?
Okay, so here, that's sort of ideas about future work, so to speak. Right, so in this model, it's not a very, we don't have a meaningful interpretation of them in the context of the model. So how I would think about them is that, as I mentioned, that a credit card, you open that letter, there's maybe 20 numbers in the letter. Okay, there's the interest rate. There's the interest rate if you go above your limit. There's the interest rate if you take money out of the credit card. There's the credit balance. There is, the annual fee. There is any rewards you might receive. So this is a multidimensional object. And one interpretation, the one that seems, sort of at the gut level, perhaps meaningful, is that it's actually very costly to compare across these multidimensional objects. Now, I'm not going to hang my hat on that interpretation. Okay, it could be something else, but that's one that doesn't seem completely crazy to me. now, I think that would, however, be a fruitful next step for working about why, what could it be? Why would it be that, it's so costly to compare across different credit cards?
But a second ago, you were hanging your hat on exactly that interpretation. You were telling us how important this one singular aspect is relative to everything else.
No, but I'm not suggesting that people make the decision just based on that. It's just that right. So
I think it comes to me. It comes across as you're trying to have it both ways. That there is the singular feature that you're going to look at in the data that summarizes everything, and that people don't make mistake regarding that feature once they open the envelope. But yet, when you're talking about interpreting a very high cost of opening an envelope, now we're getting into all of this. Something that came up in a discussion, I don't know if you've seen it, where Alessandro pointed out that people who do have multiple credit cards, people who carry balances on multiple credit cards, actually don't do a very good job of repaying the high interest rate accounts first. In fact, they seem to basically just proportionally pay all of their accounts. So it doesn't seem that for a whole bunch of people, this interest rate we're talking about is that much of a big deal. See, some people in the extreme are making $500 a year mistakes. I think if you looked over all people who got a credit card, the number is going to be a hell of a lot smaller.
No, this is the average number. This is the average number. So,
average number not amongst people who accepted the card. This is
so
maybe.
if you look at the average balance, and you move somebody from the 90th to the 10th percentile, that's what you get. The average balance that people pay.
Conditional habit
among people who have who roll over their balance. Yes.
Right.
So can I say one thing that sounds frivolous?
Go for it.
Hopefully there is something useful in the back. I was talking about movies today before it was Exterminating Angel. Let me go to Glengarry Glen Ross, which is the ultimate movie about salesmen. They were obsessed with the leads. The leads is essentially an index of customers by the cost, the marginal cost of, by how likely it is that they are suckers. Now, there are certain things you did something very on, which is, let me see if this unobserved characteristic A can carry out some of the weight of accounting for the dispersion. That was nice. I just said, well, not really, because given my assumptions of independence and equal costs across all A's, which are assumptions that are very heavy, there is no reason to offer a low credit card. But if these guys are operating on different markets and the sets of people that receive these offers are not the same. So if customers are indexed, for example, by how much of a sucker they are, and companies have that kind of list, you could have some competition in terms of product differentiation there. The financially educated guys that get very few offers, all of them with a high interest, while the other ones get a bunch of continuous offers that are very high. So there's be something like that. So I would imagine that you would have at some point when you submit this, which I think is a lovely paper, you would have to do a little bit of an extra effort to convince that you have done enough of accounting for alternatives. And as I was telling you one about this, for example, you should document that there is no dispersion across people between the number and quality of the offers that they make. So your assumption that everybody gets this Poisson number of offers is a good one. And a couple of other things you'll have to do there. That's what I meant by Glengarry Glen Ross. The leads, the information about whom to target these things is a valuable one.
Yes. Are you Jack Lemmon or Alec Baldwin in that? But okay,
Yeah.
so then, okay, no, that's a good point, Victor. So here, I think, so we did a much more detailed analysis on the accepted offer distribution. You're asking us to do more detailed analysis on the offers that people receive, which it's a point well taken. This is where we don't have the micro data for that, unfortunately, but this is perhaps something we could think about more. But yeah, I take the point. I think is a very relevant one, very good one. Now on a different point, which is not so good, back to Igor. Igor, I'm not. So I don't disagree very forcefully with what you said. It's just that I don't particularly care what interpretation I give to this high cost of examination. I gave you one. You say that particular interpretation perhaps is not fully consistent with focusing so much on the interest rate. That might be, but okay, we can try and find another one. I mean, I'm not wedded on that for this paper. I'm saying this. This paper seems to suggest that examining this examination effort in more detail is the way to go. Is important. And then it might be something that's not examination effort, but that looks like it, that does the deal. I mean,
well, there is something hidden in your counterfactual that is tricky, which is at zero cost they learn the alternative offer distribution, which seems to me like a overdose of heterogeneity and better policy analysis. Then they make more effort because they think they are more rewarding now. Okay, but imagine that's hard to learn because of the same lack of attention that you have to other things. Then you should report what would be the equilibrium if they were not to adjust their opening policy, the distribution of letter opening after the policy change, because you might see much fewer benefits.
Yeah, I see.
I would like to know, because you're asking people to be really aware. So the cause is not to be informed, because it's just of opening. In that sense, that Igor is saying, okay, that I managed to learn the new distribution of interest rates in the mail, and I still don't open it.
Yeah. Okay. I don't. Yeah. I think that's not. I don't disagree in the sense that. So before we wrote the paper, we wouldn't have known. Okay, that this examination cost is so important. And now that we do, I agree that it's worth looking a bit further, including perhaps amending the model accordingly.
So I guess you would need a higher fixed cost, right? So it's sort of a hassle cost to worry about those things.
Well, I mean, anyway, amending the model. We don't need to, I guess, do it right now on the spot. I agree with that. It's just that this is an outcome. We're discussing the outcome of this paper. Before we started with this paper, we didn't have that. We couldn't have that discussion because we wouldn't know that this cost has been estimated to be so high. So, in some sense, I would say this is sort of a very good idea for the next, for following work. But yes, I agree with the general direction. I completely agree.
Yeah, but this one you can do now, which is report the counterfactual without changing the opening policy.
Yeah.
Correct interpretation of what that is. Do you have that?
Yeah, no, I don't have that now, but I would guess that. Okay, so in some sense, this fraction with a loan would replicate the offers per borrower, but that would also affect the lender's choice. What interest rate
lenders it will be closer to the non-competitive environment that you discussed also.
Yeah, possibly, yes. Yeah, okay, that we could.
Yes, frame it like that. This is absolutely cheap.
Yeah. Yeah.
Cheap thing to say.
Mhm.
Well, can I ask one more question?
Yeah.
Just because, I don't know, when I'm done, I have to go take care of my kids, so why not? So I guess like there are other papers, I imagine, that estimate the cost of, well, I guess some of them are kind of pure switching costs, but other than, I mean, the cost of changing your mortgage rate, the cost of, I don't know, I'm pretty sure I pay too much for my cable bill every month. But to the thought of calling Comcast is just daunting to me. But they're like, I mean, so there must be quantitative estimates of some of these costs as well. Are they like in the same order of magnitude, Because I mean, this market in some sense has a lot of other stuff that you don't necessarily want to have when you just want to isolate the cost of switching or contemplating a change, right? There's the asymmetric information. There's all these other kind of rich heterogeneity in the cards. You would love kind of a homogeneous product without asymmetric information to try and estimate something like this. So, does your number look like?
Yeah. Okay. That's a good question. Yeah, I haven't compared that. I'm sure there's estimates. I don't think we haven't compared that. Let me just tell you what it is for us, because it is actually quite high. So as I mentioned, borrowers are estimated to basically examine one letter out of the 3 or 4 that they receive. Getting that to 2 letters corresponds to increasing their interest rate by 10 percentage points. So it's actually it's very high. Yeah. So yes, that would be that would be worth making that comparison. I don't know. The answer is I don't know. Yeah.
Let me give you an example to say there's another paper that estimates the cost of doing something. It's a beautiful paper by Eric French and his co-authors. They estimated the cost of putting on a tie and going to work. That was 1,200 hours a year. The amount of the fixed cost of putting the tie and going to work. So sometimes nobody evaluates that well. And it tells you there's something you want to understand better, because through these eyes, there's something special about not retiring slowly and retiring contrary. So they're saying this is the tables that he put were really scary for many of us who do something else, which we put some frictions but dispense of others, and it's the same. Wait a second. Mm-hmm. And I think that it's a very honest job to say, maybe let's give it a try with something coherent. Of course, you're not going to try the hardest. That's not necessarily your job here. But that's been pointed at the decent enough try.
Mm-hmm. Okay. Yeah.
For these things. There's a big literature out there that I'm saying all you religious people and all of us more competitive guys choose to ignore systematically, which is the literature on financial literacy. And this is a call to not patronize them because there is something there that shows up. That's the way I take this to mean, and this is a big deal in some ways. That's there.
Mm-hmm. Yeah. Yeah.
Okay. If there are no other questions, that's the end of today's seminar. And thank you everyone for participating. And thank you, Manolis.
All right, thank you very much for your comments. Yeah, thanks.
Thank you.